Welcome to Intuitive Stats Cafe. Today we are going to demonstrate an example of the one-sample student's t-test. Following our last video, here are the weights of 5 glasses which I simulated from a normal distribution. Normal means 60, standard deviation 1, so the normality assumption is automatically met. Assuming independence and random sampling, we can go ahead and implement the one-sample student's t-test. It is always a good habit to write out the null hypothesis and the alternative at the beginning, since it is clear to both the author and the readers. Here, we set up a two-sided test because we have no reason to favor either side. The null hypothesis is mu equals 60 and the alternative is mu is not equal to 60. The next step is to calculate the test statistic, which is given by this equation. This equation is where we need all those assumptions. If you are interested in the underlying math, please refer to the appendix video of this topic. X bar is the sample average. Mu0 is the designated value we are testing against. S is the sample standard deviation. N is the sample size. There is a little fun fact. S over root n is called the standard error of mu. It will be covered by a video about sampling distribution. With all the components clear, we list out the values for our example. Sample size n is 5. Sample mean x bar is 60.10. Sample standard deviation S is 0.66. You can calculate each by hand, but with larger sample size, please use a calculator. Then we plug in and calculate the test statistic 0.32. To come to a conclusion, we need either a p-value or a confidence interval. Confidence interval is covered by the video of Introduction to Hypothesis Testing, which also includes the intuition behind p-value and significance level alpha. Here, we obtain the p-value by finding the probability of getting observations against the null hypothesis, given the null hypothesis is true. Practically, we just need to know the probability of the gray area. The probability is found either by looking up a student's t-table or by computer. I haven't used a t-table since I first learned t-test. The computer says the p-value is 0.76. Then we compare our p-value to the significance level alpha. We take 0.05 here, which is smaller than our p-value 0.76. So we fail to reject the null hypothesis. In other words, we are not able to file a complaint to the manufacturer saying their glasses don't meet the standard based on the 5 data points we collect. Had we decided to implement a right-sided test, the p-value is only the right part. Had we decided to implement a left-sided test, the p-value is 1 minus the right part. Thank you for watching.